Okay, this video will go through some of the challenge problems for the upcoming test. Here's number 5 on the download, and I'm comparing my usual driving speed to an increased driving speed. If I increase my usual speed by 12 kilometers an hour, if I let R represent my usual speed, then R plus 12 would represent my increased speed. It takes me 1 hour, one less hour to drive to work if I could drive faster. My distance to work is 360 kilometers both ways. The challenge comes into the time column, and then the challenge comes in how I set the equation up to solve for R. My usual time could be represented by 360 divided by R. If I save 1 hour, then my challenge becomes expressing this time properly. I'm comparing it to my usual time, which is 360 over R. And if I'm saving 1 hour, it would be my normal time minus 1. So the equation that would allow me to solve for R comes from the second row of the table. If I have my rate of R plus 12 times my distance, times my time, equaling my distance of 360. So now I have choices for solving for R. I could use the LCD method. I got a common denominator in here and then multiplied everything by R over 1. Or I think actually the cleanest, easiest way to do this is just to simply multiply the binomial pairs together. So I have R times 360 over R, leaving me with just 360. R times negative 1. (12) times 360 over R. And then I have positive 12 times negative 1. You can see that the 360s on each side will eliminate each other. And then I could use an LCD method on what remains to eliminate the R fraction right here. So I'm going to clear the board and start from here. I'm going to start with using the LCD method. Actually, let me just erase this. We'll just salvage what's left. 360, 360, canceling each other out on both sides. This is equaling 0. If I multiply what remains by R over 1, since this is the only denominator in the whole expression. And now I end up here. I have negative R squared plus 4,320 minus 12R equaling 0. I'm going to clear the screen and pick up with this quadratic and factor it to answer the question. So I have my usual rate, my increased rate, and I'm dealing with factoring quadratic, which I will rewrite so that I have a positive lead coefficient. My constant's negative, so I'm looking for factors that differ. R plus 72 gives me a negative root, which I can't use. R minus 60 gives me a positive root. So my normal rate is 60, my increased rate is 72 miles per hour. So the challenge comes in how you represent the time, and then once you set the equation up, multiplying the binomials out with the fractions, and then you end up with a quadratic which you can factor. Number 6. I have 2 machines. I have a new machine and an old machine, and their rates are quoted for covering 1 kilometer of highway. The work rate for the new machine is 1/10. The work rate for the old machine is 1/18. time is what I don't know. And the way I chose to solve this, I just kept it as a basic work rate problem. Setting it equal to +1 to represent one whole job. I used a common denominator of 180. And then my interpretation of the problem was like this. I will explain how I interpreted the problem. So this represents covering 1 kilometer of highway. And the problem's asking me, how long would it take to cover 21 kilometers of highway? So I simply took this fraction and I multiplied it by 21 to represent 21 kilometers. And when I did that, I ended up with the integer 135. And since everything is given in hours, that answer is interpreted as 135 hours. So here I have a rail line between two cities, and this is just, you're going to end up with a rational equation to solve to get to the answer for this one as well. So the shorter segment, I will let it be x. The longer segment is 96 kilometers longer than the shorter segment, so that's x plus 96. And then the total track would consist of the short segment plus the long segment. So it's 2x plus 96, representing the entire track. Time is not mentioned, but rates, I put my distances in the wrong column. Okay, now my rates. My rate over the shorter segment is 60. My rate over the longer segment is 120. And my rate over the entire track is 100. So if I set up my time column, since time's not mentioned, and remember time is just d over r. And my time on the short segment plus my time on the long segment would equal the time it takes me to cover the entire track. So having this explanation and the equation set up, you can see that I have a fractional equation to solve. And going through all of the algebra, at the end, x equaling 32. So to get to the answer, you come back to each segment of the track, letting x be 32 to get the final answers. So those are your challenge problems for the test. Number 5 would be a bonus.